Morning everyone, my name is Mark Davis, also known as MBD, and this is Methodoku Masterclass No.2. All the production quality of a failed homemade sourdough loaf, but the content of a rich figgy Christmas pudding. Right, let's get started. In this video we're going to show you how you find the name of the method that corresponds to the solution to your Methodoku. So Methodokus, just to recap, and if you've forgotten what they are, buy my ACE book, which is full of them, or check out Methodoku Masterclass No.1. But they are a logic puzzle. When we've solved them, we've filled all these spaces with numbers, and those numbers correspond to a method, a bell-ringing method, which somebody somewhere has rung and given a name to. But how on earth do we find that name? So that's what this video is all about. But first of all, let's quickly solve this example Methodoku I've got here, and then we'll try and find out what its name is. Right, so just to recap, Methodoku's nice simple logic puzzle based on bell ringing. The numbers are bells, and there are only two rules. The first rule is that every row of the Methodoku has got to contain every bell, every number. Second rule is that a bell can only move at most one space as it moves down from one row to the next. It can stay in the same place, it can move left or right if it's got a room for it, but it can't hop more than one place. Right, with those rules in mind, let's quickly solve this Methodoku. So I think the 1's got to go there. I think the 4's got to come down along this path step by step. The 2's got to go here, I think. 1 comes out there, and the 3 would have to go here. What next? The 2's got to join up here. The 1's going to have to come down through this path. That means the 3 can only go here. 2 must swap with it at the end, and there's only one space left for the 4. So that's our Methodoku solved. If that was a bit quick for you, replay in slow motion, or go back and check out Methodoku Masterclass No.1. Right, so there's our finished Methodoku. But which method is it? I mean, even seasoned bell ringers will look at that and go, I've got no idea what that is. So how do we find out? Well, the good news is there's an easy way. The easy way, it works if you've got access to the answers. So if you've got my Methodoku book, the answers are printed in the back, and you can use those to check. If you're reading The Ringing World, the Methodokus in The Ringing World, the answers are usually printed in the following week. And so the answers are going to be a method name, and you can use the method name to look up what the figures of the method look like, compare them back to your solution, and check that you've got it right. So let's just quickly do that with this method. So I know that this method is called Barton Little Bob Minimus. I've looked up the answers, and that's what it is. So we're going to go to an online method library. This is a pretty good one. It's on the Ringing World website. You can find the URL in my book, or you can type it in. It's bb.ringingworld.co.uk/method. And in this box down here we can type in the method name, Barton Little Bob Minimus, and there we go. We've searched for it, it's found it. Let's click on it and it'll show us what the method looks like. Now in a Methodoku you're only actually working on the first lead of the method. Some methods have lots of leads, they're all the same, they just start in a different place. But we only need to look at the first one, which is this left hand bit, these column of figures on the left, and you can see it starts 1, 2, 3, 4. The 2 and the 1 have actually been replaced by blue and red lines, but we can still fill in the numbers and see what they are. So the next row is 2, 1, 4, 3, and then 2, 4, 1, 3, and if we go through it all, that matches, what we've written as the solution to our puzzle, so we can tell we've got it right. Excellent. Right, but what if you don't want to look at the answers yet? What if you've got the solution and you want to find the method name without looking at the answers or waiting for the answers? So there is a way of doing that too, And to do that, we need to summarize this whole big grid of numbers in the form of a code called place notation. Now, that sounds scary, but it really isn't. Place notation is just a way of summarizing what happens as the bells move from row to row. So let's look at those rows. So the first movement between rows, we can see that the 1 and 2 have swapped places. Yeah. Also the 3 and 4 have swapped places. And no bell has stayed in the same position. And in place notation we call that a cross, because basically all pairs have crossed and nobody stayed fixed. Now, looking down at the next change between rows, which is here, we can see something different happens. So the 2 has stayed in the same place, hasn't moved. The 1 and 4 have crossed, yeah, but the 3 has also stayed fixed. And the place notation for that will say that column 1 has stayed fixed and column 4 has stayed fixed. So it's not really the bell numbers that have stayed in the same place, it's the columns that have stayed fixed. Yeah. And so we write down 1, 4, and it's the bells in columns 1 and 4 that have stayed in the same place. That's why it's called place notation. It's all about which bells stay in the same place, but we record the columns, not the bell numbers. Okay, hope that makes sense. Let's do a few more changes, a few more rows down, and we'll see if we can understand that a little bit better. So in the next change down, first 2 bells have swapped with each other, and the bells in columns 3 and 4 have stayed fixed. Okay, so columns 3 and 4, you can see the bells there have stayed in the same place. So that's 3, 4. Okay, next row down, the bell in column 1 has stayed in the same place, and the bell in column 4. So it's another 1, 4 for the place notation. Next row, well, everybody's crossed here, haven't they? They've swapped round with each other, so that's a cross. And finally, going to the last row, the last change of the method, the bell in column 1 stayed fixed, and the bell in column 2, and that's it. So the place notation is 1, 2. There we go. So it's pretty easy. You just have to remember, look for the bells that stay in the same place, and then write down which column numbers they're in. If no bell stayed in the same place, they've all swapped, it's a cross. Now we can write this place notation in a neater form, all on one line, like this. So we start with the first one, which is X, then we write the 1, 4, then we write the 3, 4, but we don't want all those numbers to run together, that would be confusing. So we're going to put a dot to separate those 2 bits of place notation. And again, for this 1, 4, we're going to separate it with a dot. But then it's an X, we don't need to separate that, that's not confusing. X and 1, 2 to finish. So the finished place notation for our method is X, 1, 4, dot, 3, 4, dot, 1, 4, X, 1, 2. Or you can say cross for X, that's a bit nicer. Anyway, so now we can take that string of place notation and we can put it in our search function and it'll give us the method name. Let's try that now. Okay, here we are again at the Bellboard online method library, and this time we're going to look up our method via its place notation. So instead of using the method title search, we're going to search by number of bells and place notation. So the number of bells for our method was 4, and the place notation was X, 1, 4, 3, 4, 1, 4, 1, 2. Okay, so let's press search. And it's taken us straight to Barton Little Bob Minimus. So again, if you want, you can look at the figures, the numbers here, just for that first lead on the left, and check they're right. But actually, this is the method here. That's the name that we want, Barton Little Bob. Okay, fantastic. Well, I hope you've enjoyed this little explanatory video, and I hope it's helped you understand how you can take your solved Methodoku and find out which method that it is. Now, you don't have to do that, you can just go through and solve them just based on the numbers, but it is nice to check you've got them right and to look up what the method is. Sometimes they're quite unusual methods, sometimes quite good fun, sometimes they've got amusing names, so it's worth having a look. Okay, hope you enjoy, and I'll see you next time for the next installment of the Methodoku Masterclass.